Hi guys, we're covering the next lesson, which is properties of logarithmic functions. Some of these properties you might have seen before, while others might be brand new to you. The very first property covered here is the change of base formula. If you're given a logarithm, such as the example right here, log base 4 of 25, there's no way that you know the exponent which takes 4 to be equal to 25. In that case, you have to be able to put it in a calculator. It wasn't until recently that the calculators allow you to put a logarithm in that format. What you had to do, and some of you still have to do that with your calculators, is to be able to calculate the log. You can replace this log of base a of x to be equal to log base 10 of x, and then divide that by log base 10 of your old base a. You can complete that with either log base 10 or the natural log, since you have both of those on your calculator. So to apply that property in this first example, we would have to say that the log base 4 of 25 is equal to, I'm going to do the log base 10 here. Normally we don't write the base of 10, you just do log of 25 over log of what used to be my base 4. Now I can input this in the calculator and find what it's equal to. Let me show you what that would look like on your calculator. Now, my calculator has a newer software, so I am able to input log base 4 of 25. So you can check if you have that option first. Click on Math. From there, scroll down to see if you have that log base. If you have that, you can open it and you can input your base is 4 and then move over to the argument of 25. So my calculator can actually evaluate any logarithm. Still, this change of base formula is something that you have to know, even if your calculator can calculate it. Okay. Now, if your calculator is any plain old calculator, then you can do log. Whenever you click on this button log, this is log base 10, log of 25, close the parenthesis, divided by log of 4. Close the parentheses again, and you can evaluate that. As you can see, the value is the same. We get 2.322. We can round it to 3 decimal places. So let me go ahead and write that out, and we're going to try the next example as well. Oh man, I forgot what was the answer. 2.321. That is 2.322 approximately. To evaluate the next one, log base 3 of 17, let's try that with the natural logarithm. This is equal to the natural log of 17 over the natural log of 3. Note that we can do this with any other base. For the most part, the other base is not going to be any helpful. The reason why we normally use base 10 or the natural log is so that we can input it in the calculator. All right, so let's try this on the calculator too. We have log of natural log of 17 divided by the natural log of 3. And that is approximately 2.579. And of course, we're rounding up appropriately. These next properties of logarithms are extremely important. If you are working on making like a cheat sheet that you study from for this unit, these are properties that you must know. I would absolutely recommend putting them on your study sheet. I also have those properties in the room, so you will be able to use them. So it might be a good idea to pause the video and look at each of the properties. We have product property, quotient property, as well as power property. Thank you for pausing the video. Each one of these properties is so because logarithms are inverses of exponentials. Please don't forget that. We convert the product inside of a logarithm into addition. We convert the ratio or division inside of a logarithm into a difference. Whenever you have a power inside of a logarithm, that power could be taken outside as a coefficient. Let's see how that works into an example. We're asked to write each of the logarithms in terms of natural log of 2 and natural log of 3. Well, I don't even have 2 or 3 here, so let me start by rewriting 6 as 2 times 3. Okay, now I have progress. Well, 2 times 3 is a product. So I am going to use the product rule. So sorry, not able to write very well on the bottom of my tablet. But here we're using the product rule. According to the product rule, you can split any product into the sum of the two logs. We have natural log of 2 plus the natural log of 3. This right here is our final answer. In part B, we have the natural log of 2 over 27. I still don't see that log of 3, but I do see that I have a ratio. Ratio, quotient, same thing. So I can actually split this quotient into the difference of natural log of 2 minus the natural log of 27. Well, I need to have the natural log of 3. So let me go ahead and rewrite this as natural log of 2 minus the natural log of 3 cubed. Well, over here, I do see a power. That means I need to use the power property. I can rewrite this as natural log of 2 minus that exponent can come out to the front of the log. So I have minus 3 natural log of 3. And that will be my final answer. Let's look at the problems on the back. Here, we're still using the same properties from the front of your worksheet. For the very first one, we have to use the properties to expand each of the expressions. So we're going to do something similar to the last example, but they're not telling us what to expand it with. Whenever you have a product, you can convert that to a sum of logarithms. When you do the conversion, make sure that you keep the same base all throughout. So that would be equal to the log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Well, right here, I also see a power. That means I can use the power rule. That will be equal to log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. There's nothing else that we can do. This will be our final answer. We have expanded it fully. Isn't this product looking so much nicer than this long expression? Certainly. However, there are a few things that you might be able to evaluate if you split it into 3 separate logs. So let's look at part B. Part B, we have the natural log. So whenever we're splitting it, we will be using the natural log. Automatically, I hope that you are seeing that this is a ratio. The ratio converts into a difference. So we have the log of whatever was on top of our fraction, log the square root of 3x minus 5, minus the natural log of 7. Now, the natural log of 7, you can input in your calculator and see how much that is. I suggest just keep it as the natural log of 7. I know that you can evaluate it in the calculator. Just keep it this way. Now, here I have the square root of something. Remember that the square root could be rewritten as a power. That is the natural log of 3x minus 5 to the 1/2 power. And I still have minus the natural log of 7. Now that I have a power, I can take the power and put it on the outside of my log. I have 1/2 the natural log of 3x minus 5 minus the natural log of 7. Some of you might be tempted to want to split this 3x minus 5. However, this is inside of your log, and since we have the subtraction in here, we cannot split it. If we only had the natural log of 3x, then you could. But in this case, we have found our final answer. In example 3, we're given a long expanded expression and we're asked to condense it. So the first thing that you have to do is take this coefficient and put it inside of the log. Here I have half of a log base 10, and over here I have 3 logs base 10, which is why I have to use the power property first. Okay, so that will be equal to log. I'm not going to write the base, it's assumed, log of x to the 1/2. Well, 1/2 is really the square root of x. So we have log of square root of x plus the log of x plus 1 cubed. Any sum of 2 logarithms with the same base, you could use the product rule. That will be equal to the log of square root of x times x plus 1 cubed. This right here is our final answer. For part B, we have to follow the same procedure. Power will always be done first. I do see a coefficient that I can take and put inside of that logarithm. So that will be equal to the natural log of x plus 2 squared minus the natural log of x. Now that I see the difference of 2 logarithms with the same base, I can use the quotient property, and that is equal to the natural log of x plus 2 quantity squared over x. We're almost there, guys. Just one last problem. Here, you can automatically see that you have a coefficient of 1/3, but this coefficient is supposed to multiply the whole expression. So before you can apply the power rule, you actually need to distribute that 1/3. That will be equal to 1/3 log base 2 of x plus 1/3 of log base 2 of x minus 4. Now, each one of the logarithms has a coefficient in front of it, so I can actually use the power property, and that coefficient will go inside of the logarithm, log base 2 of x to the 1/3 power plus log base 2 of x minus 4 to the 1/3 power. Now we have a sum of 2 logarithms with the same base. That means that we can use the product property, and that will be equal to the log base 2 of the product of these 2 arguments. Now, if you have a power of 1/3, this is equal to the cube root. It is the same power for both of those, which is why I can just expand that cube root. And then we have x times x minus 4. And that's an end. I'll see you guys tomorrow.